Hi guys, welcome to the video for lesson 5, and today what we're going to work on is defining what equivalent ratios are and practice solving them. Okay, so we've learned that equivalent ratios are very similar to equivalent fractions when we go to solve them. So that's a strategy that you can keep in mind today as we are working on this lesson. Oops. And my S ran off the page. Okay, to get us warmed up, there are 2 dot patterns here. I want you to pause the video and go ahead and try and solve them. When you're ready, come back and we will go over a couple different strategies. Okay, you should have paused the video and come back now. Dot pattern 1, one way you might have thought of it as they are groups of 9. So you might have thought, well, there's 6 groups of 9. So 6 times 9 would be 54, so there are 54 dots in this pattern. On dot pattern 2, you notice that these are halves. So you might have found that there were 7 going down, 6 going across, so that would be 7 times 6 is 42, which you have to divide by 2. So you might find that there would be 21 dots there. Okay, there might have been several other strategies that you tried, but that's just one that we'll go over quickly. All right, I'm going to zoom in on this recipe card here. Okay, so here's a recipe for making tuna casserole. We need 3 cups of pasta, 6 ounces of tuna, 10 ounces of cream of chicken soup, 1 cup of shredded cheese, and 1½ cups of French fried onions. Okay, so our first question says, what is the ratio of ounces of soup to, remember 2 is colon, 2, and I'm going to use different colors. If you want to grab highlighters, you're welcome to do that. 2 the cups of shredded cheese. 2, so we have another split, the cups of pasta in one batch. So I'm going to find the amount of ounces of soup that we will need. So we will need 10 ounces of cream of chicken soup. So 10. Then next is my cups of shredded cheese. I will need 1 cup of shredded cheese. And the last one is the cups of pasta. Looks like I will need 3 cups of pasta. So my ratio for one batch would be 10 ounces of soup to 1 cup of cheese to 3 cups of pasta. Okay. Go ahead and keep that ratio in mind because we're going to use it here in the future. Okay. So for question 2, it's going to ask us how much of these ingredients would we need if we were going to make different sized batches. So if we were going to make twice the amount of casserole, twice means that we're going to take all of our ingredients times 2. So our original ratio was 10 to 1 to 3. Okay, we need to double all of our ingredients for twice the casserole, so that would be 20 to 2 to 6. Okay. Now half of the amount of casserole. That means that we're going to multiply it by half, or you can think of it as dividing by 2. Okay, so we're going to cut everything in half. So instead of 10, we would have 5. Instead of 1, we will have half. And instead of 3, we will have 1½ Okay. 5 times the amount of casserole means that we are going to multiply it by 5. So 5 times. 10 times 5 is 50. 1 times 5 is 5. 3 times 5 is 15. So that would be our ratio if we were going to do 5 times the amount of casserole. And then we have a 1/5 the amount. So we can think of that as multiplying by 1/5 or dividing by 5, whichever way kind of makes more sense to you. And so 10 divided by 5 would be 2. 1 divided by 5 might be a little bit tricky to do in your head, but remember we can write division problems like fractions. So 1 divided by 5, so 1/5 of a cup. And 3 divided by 5 we can write as a fraction as well, so that would be 3/5. So basically, if you're trying to increase the size of your batch, you're going to end up multiplying. And if you are making the size of your batch smaller, you're going to end up dividing or multiplying by a fraction. Okay. Let's look at number 3. Number 3 says, what is the ratio of cups of pasta to ounces of tuna in one batch of casserole? So cups of pasta, if we look back at our main recipe card, we found that cups of pasta is 3. So we're going to have 3 cups pasta, 2 ounces of tuna. So let's look back here. For ounces of tuna, it looks like we have 6 ounces of tuna. So our original recipe for one batch is 3 cups pasta to 6 ounces of tuna. So how many batches of casserole would we be able to make with the following ingredients? So now we're doing it kind of backwards. Now we have X number of ingredients, and they want to know how many batches could we possibly make. So 9 cups of pasta and 18 ounces of tuna. Well, 9 divided by 3 is 3, and 18 divided by 3 is 6. So we would be able to make 3 batches. If you think of that, our original ratio was 3 to 6, and now we have 9 to 18. Kind of like multiplying equivalent fractions times 3 by each side, so we could triple our batch. If we had 36 ounces of tuna, I'm going to do this one in a different color so it stands out, and 18 cups of pasta. Now make sure you pay really close attention to the order, okay? This has pasta listed as second. So we'll start with our 3 to 6, and it would be 18 and then 36 tuna. Okay, remember the order is really important. Pay attention to that because they will try and trick you. Okay, to get to our new ratio, we're going to have to multiply each side by 6. So that means that we could make 6 batches. Okay, and our last one, if we have 1 cup of pasta, so 3 pasta and 6 tuna, and then we have 1 cup of pasta and 2 ounces of tuna. So we don't have enough to make 1 batch in here, so that means our batch is going to be a fraction size. So we're going to have to divide. So 6 divided by 3, 3 divided by 3, that means that we can make 1/3 of a batch. We don't have enough for a whole batch. Since we were dividing, that means we're going to have a fraction size of a batch. Okay? We are going to skip the Are You Ready for More part. If you feel like doing that on your own, be my guest if you would like a challenge. Okay, so it says that the ratios 5 to 3 and 10 to 6 are equivalent ratios. Let's see why they are equivalent. Okay, 10 to 6 and 5 to 3 are equivalent because we can multiply each side of our ratio by 2 and they equal one another. It wants to know if the ratio of 15 to 12 is also equivalent to these. Okay, so at first you might think, well, I'll write 15 to 12 down here, and, well, there's no way I can get from 10 to 15 and 6 to 12. That does the same thing on both sides. Let's also check if we can do 5 to 3 and 15 to 12. Well, I can do times 3 over here, and I can do times 4 over there. Okay, that would mean that they are not equivalent ratios because we are not doing the same thing on both sides of our ratio. Also, if you look over here, you might say, well, I can do +5 and +6. Not doing the same thing on both sides, so that is not equivalent. Okay, our next question is 30 to 18 equivalent to these. So let's check if it's equivalent to 5 to 3. Okay. We can do times 6 times 6. Since 5 to 3 is equivalent to 30 to 18, and 5 to 3 we know is equivalent to 10 to 6, that means that yes, these are all equivalent. If you would like proof here, we can do 10 to 6 and 30 to 18 multiplied by 3 multiply by 3. Okay, come up with 2 more examples of ratios that are equivalent to 5 to 3. Pause the video, and then when you come back, we'll see if you thought of any of the same ones as I did. And if you have different ones, that is also great as well. Okay, a couple of examples that I came up with would be 20 to 12, 50 to 30, 25 to 15, and 40 to 24. Okay, if you want to go ahead and check any of those, you can. I promise you they are all equivalent. Okay, number 4. How do you know when ratios are equivalent and when they are not equivalent? Okay, they are equivalent when you can multiply both parts keyword multiply. We're not talking about adding, subtracting. When you multiply both parts by the same number. Or if there are 3 parts to the ratio, multiply all 3 parts. So maybe instead of both, I'll change this to all parts. I'm going to zoom out so now we can see the whole thing again. Okay, along with multiplying, sometimes we might also divide. Typically we will be multiplying, but know that we may possibly divide as well. This is not talking about adding and subtracting at all. All right, next we're going to write our best definition of an equivalent ratio. Okay, an equivalent ratio expresses the same relationship between numbers. Okay, found by multiplying or dividing. By the same number. And let's also make a note about how they are similar to equivalent fractions. Remember, if I'm going too fast, it's okay. You can pause the video, rewind it. That is perfectly fine. All right, for number 6, we're going to skip making a visual display just because we're short on time for the sub, and I want to make sure you guys have time to work on your homework in class. So, for your lesson summary, all ratios that are equivalent to A to B can be made by multiplying both A and B by the same number. This is the most important thing for today. Okay, here is an example. Okay. Here is another example. Here is a non-example. Okay. Oops, sorry, I didn't realize that was off the screen. There you go. So, a couple examples. Multiply by 2 on each side. Multiply by 1/3 on each side. Or you can think of it as dividing by 3 if you want. This last one is not a good example because 9 times 2 is 18, but 6 times 2 is only 12. So that would not be an example. Okay, when you're done with the video, go ahead and show your notes to the sub. They will get you your homework problems, and those are due tomorrow.